Have you ever wondered what quantum mechanics is? Beyond all the hype, let's break down the real science behind the universe's strangest secrets. First up, at the tiniest scales, atoms, electrons. PHOTON's reality isn't solid. It's probabilistic, wave-like, and even observer-dependent. This starts with wave-particle duality. A quantum object, like an electron, is literally both a spread-out wave and a localized particle. The famous double-slit experiment shows this perfectly. When no one's looking, an electron acts like a wave, passing through both slits at once and interfering with itself. But the moment you try to measure which slit it went through, it snaps into a particle, choosing just one path. This leads to superposition. A quantum system can be in multiple states at the same time. Think of a quantum bit, or qubit, being both a 0 and a 1 simultaneously. This isn't just a weird idea. It's the foundation of quantum computing, allowing for calculations that are impossible for normal computers. The system only picks one state when it's measured. Now for the one that sounds like magic: entanglement. Einstein called it spooky action at a distance. You can link the particles so that measuring one instantly affects the other. No matter how far apart they are, even across the galaxy, if one spins up, the other instantly spins down. This is real and is the basis for quantum teleportation and unhackable quantum cryptography. While it feels like a cosmic connection, it's not proof of psychic abilities, but it's the closest thing science has to non-local consciousness. What about the ether? That old idea of a space-filling substance? Well, modern physics has something even weirder: the quantum vacuum. It's not empty. It's a seething, buzzing field of virtual particles and energy fluctuations. Particles can literally pop in and out of existence. This vacuum can even push things, which is a proven phenomenon called the Casimir effect. So, when scientists say the quantum vacuum is like a new ether, they're talking about a scientifically valid medium, not the old-fashioned version. Then there's quantum tunneling. Particles can pass through barriers they shouldn't have the energy to cross. Imagine throwing a ball at a wall, and it just appears on the other side. This happens all the time at the quantum level and is essential for everything from nuclear fusion and stars to the electronics in your phone. Could a person walk through a wall? In principle, yes, but the probability is so astronomically small. It would take longer than the age of the universe to happen. So, what is everything really made of, according to quantum field theory? Reality is built from underlying fields. There's an electron field, an electromagnetic field, a Higgs field, and so on. What we perceive as matter, like an electron, is just a localized vibration or ripple in its field. Forces are exchanges of energy between these fields. In a very real sense, the universe is made of vibrating energy patterns. This brings us to consciousness. Does consciousness create reality? The observer effect is real, but it refers to a physical measurement interacting with a system, not a mind. However, the true nature of measurement and the role of the observer are still huge. Open questions in physics that even the experts debate. Let's connect this to plasma. Usually, plasma, that superheated state of matter, behaves classically, but in extreme conditions, like inside stars or fusion reactors, you get quantum plasma. Here, you see quantum effects like tunneling and even behaviors that resemble superconductivity. This is where the world of plasma physics directly intersects with the quantum realm. Finally, zooming into the smallest possible scale, we find what physicists call quantum foam. This is space and time itself, bubbling and fluctuating at this Planck scale. Tiny wormholes and new topologies might be blinking in and out of existence. We can't see it, but it's a core prediction of theories trying to unite gravity with quantum mechanics. So, from waves and particles to spooky connections and a buzzing vacuum, the quantum world is genuinely strange, and we've only just begun to understand its rules. Thanks for watching. If you enjoyed this deep dive, don't forget to like and subscribe for more explorations into the true nature of reality.